Imagine waking up to a day like any other, only to have it interrupted by an explosion so powerful, it flattens 80 million trees in an instant. Welcome to the Tunguska Event. This monumental event occurred in the year 1908 in a remote, sparsely inhabited region of Siberia near the Tunguska River. This explosion is considered one of the most potent in recorded history. Despite its magnitude, no human life was lost, owing to the region's isolation. Yet, the event's shockwaves were felt hundreds of miles away, and the sky lit up as if it were day. The Tunguska Event's power and mystery have fascinated scientists and history enthusiasts alike for well over a century. And the cause of this massive explosion remains a mystery that scientists are still trying to solve. June 30th, 1908, started as an ordinary day near the Tunguska River, until an event of unparalleled magnitude unfolded. The tranquility of the remote Siberian wilderness was shattered by a colossal explosion, a blast so immense that it flattened an estimated 80 million trees across an area of 830 square miles. Eyewitnesses to this cataclysmic event reported seeing an intense bluish light streaking across the sky, a spectacle followed shortly by an ear-splitting bang. The shock waves generated by the explosion were so powerful that they were felt hundreds of miles away. Imagine, for a moment, the sheer force required to cause such widespread devastation, the bewildering sight of an entire forest laid flat in the blink of an eye. The aftermath was a scene of total devastation, a vast expanse of flattened forest, a silent testament to the raw, uncontrolled power of the unknown. The explosion was so powerful it was heard and felt hundreds of miles away. The Tunguska event quickly attracted the attention of scientists, despite the challenges. The remote location of the explosion, deep in the Siberian wilderness, made investigation difficult. The first scientific expedition to the site did not take place until almost 2 decades later, in 1927, led by Soviet scientist Leonid Kulik. Kulik, hearing stories of a massive explosion years earlier, was convinced that he was on the trail of a massive meteorite impact. His expedition was grueling, trekking through inhospitable terrain, battling mosquitoes and frigid temperatures. When they finally reached the supposed epicenter of the explosion, what they found was baffling. Instead of a meteorite crater, they discovered an area of flattened trees spread across an 830 square mile area. The trees lay radially, as if knocked over by a massive shockwave from above. Yet, there was no impact crater to be found, no meteorite fragments, nothing to suggest a typical meteorite strike. This left Kulik and his team with a conundrum. If it wasn't a meteorite, then what had caused such destruction? They proposed various theories. Could it have been a comet, made mostly of ice, which would have evaporated upon impact, leaving no trace? Or perhaps an incredibly dense meteorite that exploded in the atmosphere, causing a shockwave but leaving no physical evidence? These early theories sparked a debate that continues to this day. Each one had its merits, but also its drawbacks. A comet, for instance, would explain the lack of physical evidence, but comets are not typically associated with such large explosions. An atmospheric explosion of a meteorite, on the other hand, could cause a massive shockwave, but it seemed unlikely that no fragments would be found. Despite their best efforts, the cause of the Tunguska event remained a mystery. These early investigations, however, laid the groundwork for a century of scientific curiosity, sparking a quest for answers that continues to captivate us to this day. Was it a meteorite or a comet? This has been the subject of ongoing debate among scientists. There are distinct characteristics associated with each that could potentially provide clues to the true cause of the Tunguska event. Meteoroids, for instance, are small pieces of debris in our solar system. They are made up of rock and metal and become meteors or shooting stars when they enter Earth's atmosphere. If a meteoroid survives its fiery descent and lands on Earth, it becomes a meteorite. Many scientists believe a meteorite caused the Tunguska event, mainly because of the devastation scale. The impact of a large meteorite could certainly generate the energy required to flatten millions of trees. On the other hand, comets are composed of ice, dust, and rock. These dirty snowballs originate from the outer regions of the solar system and can create spectacular displays when they come close to the sun, as the heat causes the ice to vaporize and create a glowing coma or tail. Some scientists propose that a comet caused the Tunguska event, as comets can also cause significant damage upon impact. However, the absence of a crater at the Tunguska site could suggest that a comet exploded in the atmosphere before reaching the ground, which would align with the lack of impact crater typically associated with such events. The evidence supporting each hypothesis is intriguing, yet inconclusive. For instance, While scientists have found tiny spheres of silicate and magnetite in the Tunguska region, which could be remnants of a meteorite, they have not found definitive fragments of a large meteorite. Similarly, while a comet's explosion could explain the lack of a crater, the absence of typical comet residue such as water or cyanogen makes this theory less certain. While the debate continues, the Tunguska event has undeniably left a significant impact on our understanding of celestial bodies. The mystery surrounding this event underscores the importance of continued exploration and research into the fascinating and sometimes perilous universe beyond our planet. The Tunguska event didn't just flatten trees, it also left a lasting mark on our atmosphere. In the aftermath of the cataclysmic explosion, a strange phenomenon occurred. Skies across the globe, from Western Europe to Central Asia, lit up for several nights, casting an eerie glow that was so bright, people could read the newspaper in the middle of the night. This was due to tiny dust particles, thrown high into the atmosphere by the Tunguska event, scattering sunlight across the sky. This atmospheric effect was not just a curious spectacle, but a pivotal moment in scientific understanding. The Tunguska event provided a unique opportunity to study the impact of celestial bodies on our atmosphere. Scientists began to understand how such an event could influence atmospheric composition and dynamics, leading to widespread weather and climate effects. Moreover, this event was a wake-up call to the global community. The realization that a celestial body, whether it was a meteoroid or a comet, could cause such devastation, ignited a global interest in near-Earth objects. Suddenly the cosmos was not just a vast expanse of beauty and mystery, but also a potential source of danger. Since the Tunguska event, we've come a long way in understanding and monitoring near-Earth objects. Scientific advancements have made it possible to track these objects and predict their paths with increasing accuracy. But the Tunguska event remains a stark reminder of the potential threats lurking in our cosmos. It's brought home the fact that we share our space with countless celestial bodies, some of which may cross our path. It's instilled a sense of urgency in the scientific community to better understand these objects and develop strategies to mitigate the risks they pose. The Tunguska event serves as a stark reminder of the potential threats lurking in our cosmos. What does an event that happened over a century ago mean for us today? The Tunguska event, while a historical mystery, holds significant implications in our modern world. In the grand scheme of space and time, a century is but a blink of an eye. The event underpins the importance of studying such occurrences, not just for historical interest, but for planetary defense. Imagine for a moment if the Tunguska explosion had occurred over a densely populated area. The devastation would have been unimaginable. Therefore, comprehending events like Tunguska is critical in preparing for potential asteroid or comet impacts. It drives the scientific community to develop better methods of tracking near-Earth objects, assessing their threat level, and devising potential countermeasures. But the Tunguska event isn't just a subject of scientific interest. It has also captured the imagination of the public, sparking a myriad of alternative theories. Some are grounded in science, suggesting a black hole or antimatter as the cause. Others lean towards the fantastical, proposing extraterrestrial involvement. While these theories may lack substantial evidence, they do add a layer of intrigue and fuel public interest in cosmic events and phenomena. The Tunguska event has also permeated popular culture. It has been the subject of numerous novels, films, and television episodes, often serving as a mysterious backdrop or a catalyst for dramatic events. Even conspiracy theories have taken a liking to this event, weaving intricate narratives around it. The enduring mystery of the Tunguska event, its scientific significance, its influence on popular culture, and its implications for planetary defense, all make it a fascinating piece of our planetary history. As we continue to explore and understand the cosmos, it serves as a reminder of the vast, often unpredictable forces at play in our universe. And therein lies the allure of the Tunguska event. It's not just a historical event, it's a symbol of our ongoing quest to understand our place in the cosmos, a testament to our resilience and curiosity as a species. As we continue to explore and understand the cosmos, the mystery of the Tunguska event remains a fascinating piece of our planetary history.